the topic probability. Now, when we talk about probability, that is the likelihood of an occurrence of an event or the numerical measure of chance. That is what we call probability. We have some types of probability that we shall discuss. We talk about experimental probability. We also have what we call theoretical probability. We have what we call experimental. Let's talk about experimental probability. When we talk about experimental probability, this is where probability is determined by experience or experiment. That is, we do an experiment for you to know the probability of an occurrence to happen. This is what is done or observed is the experiment. Whatever you do or whatever you observe is the experiment. For instance, when you toss a coin, that when you toss, each toss is called a trial, and the result of the trial is the outcome. That is, when you toss it once, that one tossing is called a trial, and what you get, either a head or a tail, is what you call the outcome. The experimental probability of a result is given by experimental probability is given by the number of favorable outcomes or the total number of trials. The number of favorable outcomes or the total number of trials. Example: a boy had a fair die with faces marked 1 to 6. A die, that is a small die that is labeled 1 to 6. He threw this die up 50 times. He threw the die 50 times. And each time he recorded the number on the top face. The result of his experiment is shown in the table. So he had a die labeled 1 to 6. And then he threw it up 50 times. And each each time he had to write the number of times a face is shown up. For instance, when he threw, the several times he threw, 1 appeared 11 times, 2 appeared 6 times on the top, 3 appeared 7 times, 4 appeared 9 times, 5 appeared 9 times, and 6 appeared 8 times. Now, from here you can find the experimental probability of getting a 1 and a 4, of getting a 1 and a 4. Experimental probability of getting a 1 and that experimental probability of getting a 4. Remember the total outcome, that is the outcome is 50 because you are doing 50 times. So we know that the probability of an event occurring is the number of favorable outcomes or the total number of trials. Favorable outcomes for a 1 is 11. The number of trials he did it is 50 times. And the favorable times for a 4 is 9. So probability of a 1 is 11 over 50 because 1 appeared 11 times out of the total trials that he did, 50 of them. And a 4 appeared 9 times, like we can see here, out of the 50 trials he made. The number of trials were 50, and how many times the favorable outcomes, how many times 11 appeared, how many times 9 appeared. So it is 9 out of 50. That's the probability of getting a 4 and the probability of getting a 1 face. Now, let's take an example 2. From past records, out of 10 matches a school football team has played, it has won 7. How many possible games might the school win in 30 matches? So if we follow the previous records, that are out of 10 matches a school football team has played, it has won 7. Out of 10 it has won 7. How many possible games might the school win in 30 matches? 10 matches, it is 7. What about 30 matches? You ask yourself. So what we do, the probability of winning in one match, it is 7 out of 10. Probability of winning one match is 7 out of 10 because the winning was 7. Winning was 7 out of 10 possible matches. So probability of winning one match is 7 out of 10. Therefore, that means the number of possible wins in 30 matches will be 7 out of 10, that is, you are likely to win in one match, times that of them, which means 21 matches. So, out of 30 games, is likely to win 21 matches. Now, let's talk about range of probability measure. Range of probability measure, that is 1. That means if a probability of an event A occurring, that is a probability of an event A occurring, and this to mean probability of with an event A means probability of an event A not happening. That is probability of an event A not happening. So probability of an event A not happening, it is 1 minus the probability of event A happening, meaning that probability of event A not happening plus probability of event A happening equals to 1. So the range of probability measure is 1. That is, we deal with fractions, that is, probability it is less than 1. It can be fraction, a quarter, a half, and all that up to 1. Or when you're dealing with percentage, probability of an event happening is 100%. Now, probabilities are expressed as fractions, decimals, or percentages, like I've said. Fractions, decimals, or percentages. And then, when we talk about a probability space is a list of all possible outcomes. A list of all possible outcomes is what we call a probability space or a sample space. Another name that can be used for probability space is sample space. So if you're asked to draw a probability space or a sample space, you have to list all the possible outcomes. That's what we call, like the one we had we saw in the table, that was a probability space or a sample space. The coin is such that the head or a tail have equal chances of occurring. You realize that for a coin, when you throw up, all of them have equal chances of occurring. The event head or tail are said to be equally likely or equiprobable. They are said to be equiprobable, meaning that they are equally likely to happen. A head is equally likely to occur, or a tail is likely to occur when you throw or you toss that coin, when you toss the coin. Now, when we talk about the theoretical probability, this can be calculated without necessarily using any past experience or doing an experiment. That probability that you can calculate without doing an experiment or without considering the past experience, then that one we call it a theoretical probability. Now, theoretical probability for an event occurring equals to the number of favorable outcomes or a total number of outcomes. Remember, now we are not using the trials, the number of trials. We are talking about the total number of outcomes. That is the number of favorable outcomes or the total number of outcomes. And example 1, a basket contains 5 red balls, 4 green balls, and 3 blue balls. If a ball is picked at random from the bucket, find A, the probability of picking a blue ball. So we know we have 5 red, 4 green, 3 blue. And a ball is picked at random from the basket. Then we find the probability of picking a blue ball, the probability of not picking a red ball, the probability of not picking a red ball. Remember that all the balls are 5 plus this, that's the total number of outcomes. They are 5 plus this is 9 plus this is 12. That's plus 3 to get 12. So let's look at the solution. So the total number of balls we have said they are 12, and the number of blue balls are 3. And therefore the probability of picking a blue ball will be 3 out of 12. Probability of picking a blue ball is 3 out of 12. That's the probability of picking a blue ball, because it is the number of favorable outcomes. Whatever is favored now is blue, which is 3 out of the total number of outcomes, which are 12. Now, the number of balls which are not red is 7. You realize the number of balls, that's the probability of not picking a red ball. The number of balls that are not red, remember red there are 5, and here we have now 4 and 3. So these are the balls that are not red, they are 7. And therefore, the probability of not picking a red ball, it is 7 out of 12. Those that are favorable, that's you are likely to get 7 of them out of 12 that are not red. Now, example 2. A bag contains 6 black balls and some brown ones. We have black balls and some brown ones. So we don't know the number of brown ones, but we know 6 of them are black. If a ball is picked at random, the probability that it is black is 0.25. Find the number of brown balls. So what we do, we let the number of balls, let the number of the total balls to be x. Meaning that brown balls are x minus 6. So then the probability that a black ball is picked, it is 6 over x. If you pick 6 over x is the probability that brown balls are picked, because black balls are picked. Probability that black balls are picked is 6 over x. The total number of balls are x. And that means 6 over x. 6 over x is the same as 0.25 because we are told the probability that it is black is 0.25. So 6 out of x equals to 0.25. And therefore, you find for x will be equal to 24. That is 6 divided by 0.25. 6 divided by 0.25, you'll find x. 6 divided by 0.25, you'll find x, which gives you 24. So the number of balls were 24. And you ask the number of brown balls. The number of brown balls will be 24 minus 6. Will be, the total number are 6, and therefore the brown balls are 24 minus 6, which is 18. Now, you need to know that when all possible outcomes are countable, that we can count them, if they are countable, they are said to be discrete. Then we say they are discrete. Now, types of probability events. We have what we call combined events. These are probability of 2 or more events occurring. Probability of 2 or more events occurring, we call them combined events. Probability of 2 or more events occurring, we call them combined events. We also have what we call mutually exclusive events. The occurrence of one excludes the occurrence of the other. For instance, if we say that if I travel by foot, that means I exclude the possibility of traveling by car. So that is mutual exclusive events, meaning that the traveling by car excludes the possibility of you traveling using a foot. So that means they are mutually exclusive events. That's occurrence of one excludes the occurrence of the other. So usually if one occurs, the other cannot occur. So that one we call them exclusive, that is mutually exclusive events. That is occurrence of one event depends on the occurrence of the other. If A and B are two mutually exclusive events, then A or B, meaning that A occurs or B occurs. Both of them cannot occur. And when we use the term or, it means you add. It is A or B. So it means you can either use A or B. So it is A or B. When we talk about or, we add. And when we talk about and, we multiply. So then probability A or B means that it's probability of A plus probability of B. For example, when a coin is tossed, the result will either be a head or a tail. It will be a head or a tail. So the probability of a head occurring excludes the probability of a tail occurring. So example, if a coin is tossed, we have probability head plus probability of that tail occurring. If a coin is tossed, then we shall have probability of a head occurring or probability of a tail occurring. And because we use the term or, we add the two, and a half plus a half is 1. So the probability of a head occurring is a half, and the probability of a tail occurring is a half. Now, we need to note that if or is used, then we add. Let's talk about independent events. Two events A and B are independent if occurrence of A does not influence the occurrence of B, occurrence of A does not influence the occurrence of B, then we say the two events are independent, and vice versa. So if A and B are two independent events, then when we talk about the term and, we multiply. That is, the probability of them occurring together is the product of their individual probabilities. That is, product of A and B. Probability of A and B, it means probability of A times probability of B. You need to know that yes, that is example we discussed about. A boy throws a fair coin and a regular tetrahedron with its four faces marked. A tetrahedron, remember, it's four-sided. The tetrahedron is four-sided. Regular tetrahedron and a coin. He throws them with its four faces marked. Then, that is, we have 1, 2, 3, and 4. Find the probability that he gets a 3 or on a tetrahedron. He throws a fair coin and a tetrahedron. We find the probability that he gets a 3 on the tetrahedron. Now, and a head on the coin. He gets a 3 on the tetrahedron and a head on the coin. So we need to draw the probability space first. So we have these events are what? Are independent events. You realize that are independent events. The probability of a head occurring does not affect the probability of a number 3 occurring or another number between 1 to 4. So probability of a tail occurring does not prevent the probability of another number like 2 or 1 occurring. So that we call them independent events. So probability of a head occurring is a half, of course, and the probability of a 3 occurring is a quarter. So when we talk about probability of getting a 3 and, so we shall multiply. Therefore, probability of head and 3, it is probability of head times probability of 3, which means as a quarter times a half, which gives you 1/8. 1/8. Example 3. A bag contains 8 black balls and 5 white ones. If 2 balls are drawn from the bag, one at a time, the bag contains 8 black and 5 white ones. So that means the total is 13 balls. Now, find the probability of drawing a black ball and a white ball. Because remember, if 2 balls are drawn from the bag, one at a time, it's one at a time. We find the probability of drawing a black ball and a white ball without replacement. A black ball and a white ball without replacement. And part B with replacement. So what we do, part A, we need to understand that there are only 2 ways we can get a black and a white ball. Either drawing a white then black, or drawing a black and then a white. That one is well understood. That if you are drawing, you are asking the probability of drawing a black ball and a white ball. So you can either draw you can either draw a white then black, or, remember now we have or and we have term and. Now here we combine, we shall multiply and then there is an addition. So we can have white and black where you multiply, or black and white, you will add the 2. We need to find the 2 probabilities. So probability of white followed by black, white, black. Remember white, when we talk about white and black, the white is 5 all over 13 and the black is 8 over 13. So multiply the 2, white and black, we multiply, we get 10 all over 39. Or probability of black and white. This is probability white and black, and white was 5 and black was 8. So, and probability black and white. Black is 8 now over 13 times 5 over 13, which also gives you 10 over 13. 10 over 13, which also gives you 10 over 39, 10 over 39. So, when we talk about or, because it is the probability of this or the other one, so we add this and this one to get the probability, the two events are mutually exclusive. Therefore, probability of this and probability of this will be equal to this 10 over 39 plus 10 over 39, which gives you 20 out of 39. Part B, with replacement. This, remember, we have used it without replacement, meaning that you don't remove and return it back without replacement. But now we are dealing with replacement. When we talk about with replacement, remember here, when you removed a black one, when you removed a black, the black were 8. Black were 8. It will be 8. You removed a black one, which is 8 over 13, and then now they remained 12. If they remained 12, then the next one will be 5 over 12. And then you come the other side, you remove a white now. We shall remove a white on the other side. If we remove a white, the white, it is 5 over 13. Now the black remains 8 over 12. 8 over 12. So that's how. Now with replacement, meaning you return them, so it remains over 13 over 13. So therefore, probability of white and black will be 5 over 13 times 8 over 13, which is 40 over 169. And the probability of black and white is also the same, 8 over 13 times 5 over 13, because they does not, it is 13, 13, 13, 13. And remember, one is 13, another one is 12. 13, another one is 12. So because you've removed one and you did not replace, but here you have replaced, you remove and then you replace another one, the same color. So here, then we shall add the 2. We shall add the 2. You find this or this one, then we add the 2. So it will be 40 over 169 plus 40 over 169, which gives you 80 out of 169. 80 out of 169. Now, I want to talk an example 4. Kamau, Njoroge, and Karaoke are practicing archery. The probability of Kamau hitting the target is 2 over 5. That of Njoroge hitting the target is a quarter. That of Karaoke hitting the target is 3 over 7. Then we find the probability that in one attempt, only one hits the target. Only one hits the target. Remember, it can be Kamau hitting the target. It can be Njoroge hitting the target. It can be, so it will be either Kamau or Njoroge. Remember, and or we shall add. So, and the probability all the 3 hits the target. Then we also have none of them hits the target, and then 2 hits the target, and at least 1 hits the target. Now we start with only 1 hits the target, but A. Probability only 1 hits the target. Only 1 hits the target. It can be probability Kamau hits the target and the other 2 misses. Probability of Kamau hits the target and the other 2 misses. So it could be Kamau hitting the target is 2 over 5. These 2 missing is now, remember this 4 over 4 minus 1 over 4. This 3 over 4. And here missing is 4 over 7. So it will be 2 over 5, and the others one missing, which is 2 over 5 times 3 over 4 times 4 over 7, which is 24 out of 140. And that gives you 6 out of 35. Probability only 1 hits the target. Probability only Kamau hits and other 2 misses. Only 1 hits the target. Probability Kamau hits and the other 2 misses. Now, we also, remember we have probability Kamau hits and the other 2 misses. And then you come and find the probability Njoroge hits and the other 2 misses. Njoroge will hit will be a quarter. This times this missing is 3 over 5 times this missing is 4 over 7. And this is what you calculate there. You find 3 out of 35. And the probability now of the last one, Karaoke hitting and the rest, Karaoke hitting will be 3 over 7, This missing times 3 over 4 times this missing, which is 3 out of 5. You multiply all that, you get 27 out of 140. So it was the probability of all those. That is probability of only one hit will be probability Kamanto hit, or Njoroge hit, or Kariuki hit, while the rest misses, which you now add all of this, you get 9 out of 20. You add all of them, you get 9 out of 20. Then we continue with part B and find probability all 3 hits. It is probability of the Njoroge hitting, Kamau hitting, and Kariuki hitting. You multiply all of them. It's all the 3 hitting. It is the probability of A hitting, B hitting, and C hitting. So you multiply, you get 3 out of 70. Probability non-hits. Non-hits, it is the probability of this one not hitting, which is 3 out of 5. This and this not hitting, which is 3 out of 4, and this not hitting, which is 4 over 7. You multiply, and you get 9 out of 35. And part D, probability 2 hits the target. 2 hits the target is the probability of, now Kamau and Njoroge hit the target. That means Kariuki miss. Kamau and Njoroge hit the target is, and Kariuki misses that. So you multiply, or it can be Njoroge and Kariuki hit the target and Kamau miss, which is this. Or it can be Kamau and Kariuki hit the target and Njoroge misses, which is that one. Now whatever you get, you add all of them. So we shall have, therefore probability to hit is the probability of this plus this, which gives you this plus all of this, which finally gives you a quarter. Now we deal with the probability at least one hits the target. It is 1 minus probability none hits the target. We got 9 hits the target as 9 hits the target as 9 over 35. So 1 minus 9 out of 35, which gives you 26 out of 35. You need to note that probability 1 hits the target is different from probability at least 1 hits the target. Yes. Now let's look at the what we call tree diagram. A tree diagram allows us to see all possible outcomes of an event and calculate their probability. Each branch in a tree diagram represents a possible outcome. A tree diagram which represents a coin being tossed 3 times looks like this. So we shall have 3 times is tossed. This is the first toss, second toss, and the third toss. So I must see some 3 branches. 3 branches, 1, 2, 3. If you were told 2, then we must have 1, 2, first and second toss. If it is 1, it's just 1 toss. So probability, it looks at a tree diagram for the probability. Remember, probability of a head or a tail occurring is a half a head occurring and a half for a tail occurring. For the second toss, it's also half, a half, a half, a half. Head, tail, head, tail, head, tail, head, tail. So for this one, we pick this one head, tail. We come to this head, tail here. Then if it's a head occurs, again you throw. We have head, tail for that. For each and every, we make a branch for each and every head or tail. So you realize that from the tree diagram, we can see that there are 8 possible outcomes. We shall have 8 possible 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. To find out the probability of a particular outcome, we need to look all the available paths. We call them set of branches. Now, the sum of the probabilities for any set of branch is always 1. So the sum of this branch is 1. This branch is always 1. This branch is always 1. This branch. Even if we had 3 branches, if there is another branch here, then if you add all of this, must give you 1. If it gives you less than 1, then you realize you are wrong somewhere. It must, if it's a branch, a whole branch, even if there are 3 here, then this probability plus this probability plus the third probability must give you 1. If not, there is a problem somewhere. Let us You need also to note that in a tree diagram, to find probability of an outcome, we multiply along branches and add vertically. We multiply along branches and add vertically. The probability of a head is probability head, which is half times half times half, which is 1/8. Probability two head and tail, it's probability head, tail, probability head, tail, plus probability head, plus probability tail head. So you calculate that and get 1/8 plus 1/8 plus 1/8, which gives you 3/8. Now another example 1 now. If we have a bag A containing 3 red marbles and 4 blue marbles, we have a bag A. This is bag A, contains red marble and blue marble. Bag B contains bag A and bag B. So bag A, bag B. Bag B contains 5 red marble, and 3 blue marble. A marble is taken from each bag in turn. Remember, it is taken from each bag in turn, not at random. If it were at random, then first of all we could have had bag A and bag B, so that from there we choose. Maybe you can choose from bag A or from bag B. But in this case, they are taken from each bag in turn. So we shall have bag A, red and blue, and bag B. So that's how the difference at random and taken in turns. That is the difference of drawing the tree diagram. At random it could be, first of all, you get the bags A and B, so that the probability of picking from A could be a half and probability of picking from bag B could be a half. And then you continue red and blue. But in this case, they are taken in turns. They are taken from each bag in turn. So we shall have bag A and bag B. Bag A and bag B. So that we have a red and a blue. And then now we have bag B, whereby we have also red and blue. Red and blue. Then we are told that the probability bag A contains 3 red and 4 blue. So 3 out of 3 plus 4 is 7. So red is 3 out of 7 and blue is 4 out of 7. And bag B contains 5 red and 3 blue. 5 plus 3 is 8. So we shall have 5 red and 3 blue. 5 red and 3 blue. This is how the tree diagram looks like. And then what is the probability of getting a blue marble followed by red? Blue followed by red. So we shall have blue, red, blue followed by red. I think blue followed by red will be only this one. 4/7 times 5/7. 4/7 times 5/8. What is the probability of getting a marble of each color? A marble of each color. It can be red, blue, or blue, red. These two. Red, blue, or blue, red. So, like I've said, multiplying the probability, we have probability blue and red. It's 4/7 times 5/8, which is 20 out of 86, like I said, which is equal to 5/14. Probability blue and red, or red and blue, like I said, which you multiply. After multiplying, you add the two. That is 4/7 times 5/8 plus 3/7 times 3/8, which gives you 29 out of 56. 29 out of 56. Example 2. The probability that Omweri goes to Nakuru is a quarter. Remember this, there are some conditions. The probability that Omweri goes to Nakuru is a quarter. If he goes to Nakuru, the probability that he will see Flamingo is a half. If he does not go to Nakuru, the probability that he will see Flamingo is a third. Find the probability that Omweri will go to Nakuru and see Flamingo. Omweri will not go to Nakuru, yet he will see a flamingo. Omweri will see a flamingo. Then now what you do, we let the N stand for going to Nakuru. N stand for going to Nakuru. And N north. N with an apostrophe above to stand for not going to Nakuru. and F to stand for singer flamingo, and F not stand for not singer flamingo. Then from there we draw a tree diagram. So we have going to Nakuru, not going to Nakuru. Singer flamingo, not singer flamingo. So if we go to, first of all we start. The probability of Omeri goes to Nakuru is a quarter. If it goes to Nakuru is a quarter. So does not go to Nakuru is 3/4. Because they must add up to 1. Then the probability that he will see a flamingo is a half. If he goes to Nakuru, he has gone to Nakuru, probability he sees a flamingo, F is a half. Not seeing a flamingo is also a half, to make 1. If he does not go to Nakuru, that means he does not go to Nakuru here. The probability that he will see a flamingo is a third. The probability does not go to Nakuru, probability of seeing a flamingo is a third, meaning that not seeing a flamingo is 2/3. Find the probability that Omeri will go to Nakuru and see a flamingo. Go to Nakuru and see a flamingo. It will be Nakuru see flamingo is a quarter times a half. Omeri will not go to Nakuru, yet he will see flamingo. Will not go to Nakuru and see flamingo, it will be a 3/4 times a third. Omeri will see a flamingo. Seeing a flamingo is either this or this one. So it will be going to Nakuru, seeing a flamingo, or not going to Nakuru, seeing a flamingo. We multiply this, we add with this multiplication. Yes, like I've said, that is the probability goes to Nakuru to see a flamingo, is probability of going to Nakuru and see flamingo, which is you multiply a quarter times half, which gives you 1/8. Probability does not go to Nakuru and yet sees flamingos. Probability that does not go and see flamingo, which is equal to 3/4 times a third, which gives you a quarter. Probability he sees a flamingo. That is probability he sees a flamingo. It is probability not going to Nakuru and see a flamingo, or not going to Nakuru but see a flamingo. You multiply 1/8 plus. When you multiply, first of all, we got 1/8 plus a quarter. So that gives you 3/8. Let's discuss these questions. A 2-digit number is formed. A 2-digit number is formed from the first 4 prime numbers. A 2-digit number is formed from the first 4 prime numbers. Draw the table to show the possible outcomes if each number can be used only once. Each number is used only once. Calculate the probability that the number chosen from the digit number is an even number. So a 2-digit number is formed from the first 4 prime numbers. First 4 prime numbers. The first 4 prime numbers we have is 2 prime numbers. We start with 2, 3, 5, and 7. Those are the first 4. 2. You must write 2 across, and then the other. This is supposed to move this across. 2, 3, 4, 5. Such that you are told that draw a table to show the possible outcomes if each number can be used only once. Remember, it's forming a 2-digit. So if we take 2, 3, 4, 5 and 2, 3, 4, 5, so that each number is used once. If I start with I don't use in this case these 2, the upper 2, but I use the lower 2. So it will be, I'm not using the upper 2s, but I'm using the lower 2. So it will be 3, 2 lower, 5, 2 lower, and 7, 2. In this case now, here, I will not use these 3. So I'll start with, I'll not use these 3. So I'll start with 2, 3, 5, 3, and 7, 3. Then I'll not use this 5. I'll start with 2, 5, 3, 5, and 7, 5, because I didn't use 5. Then I'll not use this 7. I'll start with 2, 7, 3, 7, and 5, 7. I'll not use the 7. So these are each number used on once. These are the possible outcomes. And this is what we call a probability space or a sample space. Probability space or a sample space. And then we calculate the probability that a number chosen from the digit, number is an even number. calculate the probability that a number chosen from the digit number is an even number. So the number, even numbers, 32 is even, 52 is even, 72 is even. These are not even. They are not even. They are not even. So even numbers we have 1, 2, 3. 3 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it is 3 out of 12. Even numbers are 3 out of 12. So probability even number is 3 out of 12, which is the same as a quarter. 3 out of 12, which is the same as a quarter. That is part B. And that is how you want to answer such a question. I want to do question number 2. The probability that a boy goes to school by bus is a third, by matatu is a half. Probability that a boy goes to school is a third, and by bus, and by matatu is a half. If he uses a bus, the probability that he is late to school is 1 over 5, and if he uses a matatu, the probability of being late is 3 over 10. If he uses other means of transport, the probability of being late is 1 over 20. Draw a probability tree diagram to represent this information. What is the probability that he will be late for school? What is the probability that he will be late for school if he does not use a matatu? What is the probability that he is not late for school? Now what we do, we draw a tree diagram. I've used B, that's traveled by bus, M by matatu, and all other means. So I'll say, first of all, that the probability that a boy goes to school by bus is a third. By bus, it will be a third. By matatu, probability goes by matatu is a half. And is a half. Matatu is a half. So that means, going by other means, a third plus a half minus from 1 to give you, remember I said in a branch it must add up to 1. So you add a third plus a half, what you get, you subtract from 1, you get 1 over 6, as the probability that he traveled using other means will be 1 over 6. Now, you go to the other condition is that if he uses a bus, now you're in the bus, if he uses a bus, the probability that he is late to school is 1 over 5. So probability that he will be late if he uses a bus is 1 over 5. So if it is late 1 over 5, not late will be 4 over 5. Now, you go to the second condition, that if he uses a matatu, the probability of being late is 3 over 10. He uses a matatu, late is 3 over 10, not late will be 7 over 10. Now, you are told that if you use the other means of thought, the probability of being late is 1 over 20. Other means, late is 1 over 20, not late is 19 over 20. So from here, you can say it is BL, probability of bus and late, probability of bus and not late, probability matatu late, probability matatu not late, all that. Then we are asked that after drawing, what is the probability that he will be late for school? He will be late for school. It is either bus late, or matatu late, or other means late. So it will be a third times 1 over 5, plus a half times 3 over 10, plus 1 over 6 times 1 over 20. You get probability that he will be late for school. Probability that he will be late for school. What is the probability that he will be late for school if he does not use a matatu? He will be late for school if he does not use a matatu. If he does not use a matatu, probability that he will be late will be the probability of this, or probability of this. So it is a third times 1 over 5 plus 1 over 6 times 1 over 20. That is probability that he will be late for school if he does not use a matatu. What is the probability that he is not late for school? Probability that he is not late for school is 1 minus probability that he is late for school. Remember, we calculated what's the probability that he will be late for school. It's 1 minus probability that he is late for school, or you calculate a third times 4 over 5 plus a half times 7 over 10 plus 1 over 6 times 19 over 20. It will give you the same results. So like we have calculated, probability BL or R or okay, probability MR or probability OR, you calculate like we said that times 1 over 5 plus half times 3 over 10 plus 1 over 6 times 1 over 20, which is 1 over 15 plus 3 over 10 over 20 plus 1 over 120, which gives you 9 over 40. But you see, it is the two, like I said, the first one and the last one. Like I said, this one and this one. Because you omit this is by pass. So you were to add the two, you get 9 out of 40 again. You also get 9 out of 40. Now, probability that it is 1 minus probability of being late, like I explained, which is that 1 of 40. Now, question number 3. A bag contains 10 balls, of which 3 are red, 5 are white, and 2 are green. Another bag contains 12 balls, of which 4 are red, 3 are white, and 5 are green. A bag is chosen at random. Remember now it is at random, so it is half, unlike the other one that we did from above. A bag is chosen at random, and then a ball chosen at random from the bag. Find the probability that the ball so chosen is red. So, first of all, we have bag A and bag B. Probability of choosing from bag A is a half, and probability of choosing from bag B is a half. Now, you are told that a bag contains 10 balls, of which 3 are red, 5 are white, and 2 green. So we shall have red, white, and green. From bag A, you can pick a red, which is 3 over 10, or 5 over 10, which is white, or 2, which is 2 over 10, which is green. And then bag B, another bag contains 12 balls. There are 12 balls in bag B, of which 4 are red, 3 are white, and 5 green. So it is 4 out of 12, that's red, or 3 out of 12, which is white, or 5 out of 12 here, which is green. Now remember, A red, this is for that. Find the probability that the ball so chosen is red. Ball chosen is red, it is either from bag A red or from bag B red. From bag A red or from bag B red. So it will be a half times 3 over 10 plus a half times 4 over 12. We added the 2. That's A red or B red, that is half times 3 over 10 plus a half times 4 over 12. You shall have 3 over 20 plus 1 over 6, that gives you 19 out of 60. Question number 4. Students who performed well in an examination are to be given an outing. Students who performed well in an examination are to be given an outing. A student has to throw 2 dice. If he has to throw 2 dice. If he gets a sum greater than 8, he gets a 2-day outing. Otherwise, he gets a 1-day outing. Find the probability that a student gets a 2-day outing. So remember, you are told that he throws 2 dice. Okay, let me finish reading the question. That a student who qualifies for a 2-day outing throws a die and a coin to decide whether he gets pocket money for the 2 days or for only 1 day. If he gets a head and a multiple of 3, he gets a pocket money for 2 days. Find the probability that he is given a 2-day outing but given pocket money for only 1 day. But see, if a student gets 1-day outing, he throws a die to decide if he gets pocket money or not. If he gets a number greater than 4, he gets the pocket money. Find the probability that a student gets pocket money for 2 days. A student gets pocket money. Now, part A, we were to make, remember he threw a die to determine, we had here, a student who performed well in an examination are to be given an outing. A student has to throw 2 dice. And the dice contain numbers 1 to 6. So you arrange 1 to 6 and 1 to 6. If he gets sum greater than 8, he will get a 2-day outing. Sum greater than 8 is a 2-day outing. a 2-day outing, that's for the sum greater than 8. Now 1, 2, 2. Now we find the sum. We start with 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5, 1 plus 5 is 6, and 1 plus 6 is 7. We continue. 2 plus 1 is 3. You fill by adding all this table. Remember all of them, the total outcomes is 36 because 6 times 6 is 36. That's the total outcome. Now, if you get the sum greater than 8, and then you get 2-day outing. The sum greater than 8, 2-day outing, the probability of getting a 2-day outing, it is the sum greater than 8, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is 10 out of 36. That's probability of getting a 2-day outing. But the question was that we find, the question is that we find a student has to throw to that. If he gets a sum greater than he gets a 2-day outing. Otherwise, he gets a 1-day outing. Find the probability that a student gets a 2-day outing. Gets a 2-day outing. We find the probability that a student gets a 2-day outing. We are able to see. A student who qualifies for a 2-day outing throws a die and a coin to decide whether he gets pocket money or... Okay, so you realize that probability 2-day outing equals to sum greater than, which is 10 out of 36, which is 5 over 18, like we have said. Part B, he throws, now we have said a coin and a die. If he throws a coin and a die, gets H1, T1, H2, T2. Remember, H and 1, H and 2, H and 3, H and 4, H and 5, H and 6, T and 1, T and 2 up to T and 6. So, the question was probability of 2-day out and 1-day pocket money. 1-day pocket money. Remember the condition for pocket money, we are told about the multiples of 3. If he gets multiples of 3, that's when he gets 1-day pocket money. So first of all, we know 2-day out, probability of 2-day out and 1-day pocket money. 2-day pocket money is when he gets multiples of 3. So otherwise, that is when they are not multiples of 3, it is 1-day pocket money. Not multiples of 3, we have how many? Multiples of 3 are, these are 2. Multiples of 3, these are 2. 4. They are only 4. 1, 2, 3, 4. They are multiples of 2. And the total is how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. They are 12 minus... now we are dealing with those that are not multiples of 3. Those that are not multiples of 3 are 1, 2, 3, 4, 5, 6, 7, 8. They are not multiples of 3. We are asked about... let me go back to the question. Go back to the question and see what the question was saying, that a student who qualifies for a 2-day outing throws a die and a coin to decide whether he gets pocket money for 2 days or for only 1 day. If he gets ahead and a multiple of 3, if he gets ahead and a multiple of 3, he gets pocket money for 2 days. Ahead and a multiple of 3. Ahead and a multiple of 3, he gets 2 days. Otherwise, 1 day. Ahead and a multiple of 3, he gets 2 days. Ahead and a multiple of 3, he gets 2 days. Ahead and a multiple of 3. Ahead, just only ahead and a multiple of 3, there are how many? Ahead and a multiple of 3, this 1. Ahead and a multiple of 3, 2. There are only 2. So 12 minus 2 is 10. Otherwise, for 1 day, it is 10 out of 12. And we are asking the probability of getting a 2-day out, so it is probability 2-day out and 1 day pocket money. It is the probability of 2-day out and, so it is 5 over 18 times 10 out of 12. 5 over 18 that you got from today, and times 10 out of 12, which gives you 25 out of 108. Part C. Now what you do, you read those conditions. That is 2 days and 1 day. 2 day probability of getting 2 days is 5 out of 15. 2 day out is 5 out of 15, meaning 1 day out is 18 minus 5, which gives you 13, is 13 out of 18. Now, if we get 2 day out, probability of getting 2 day pocket money, it is 2 out of 12. 2 out of 12. Because today they were only head and the tail, head and the multiple of 3, they were only 2. It is 2 out of 12. So, meaning that 1 day pocket money, he has gone for 2 days, but 1 day pocket money is 10 out of 12, like we have said. And for 1 day, if you read the last part, so that you are able to get this condition, the last part talks about this last part C, that if a student gets 1 day outing, he throws a die to decide if he gets pocket money or not. If he gets 1 day outing, he throws a die to decide whether he gets pocket money or not. If he gets a number greater than 4, remember a die is 6. Numbers greater than 4 are just 5 and 6. He gets the pocket money. He gets pocket money. If he gets a number greater than 4, he gets pocket money. So probability of getting a pocket money is 2 out of 6. Is 2 out of 6. Probability of getting pocket money is 2 out of 6. Is 2 out of 6. Probability of getting pocket money, if it's 1 day, probability of getting pocket money is 2 out of 6. Otherwise, not getting pocket of money, it is 4 out of 6. So I'm asked that I find probability of getting 2 day out and 2 day pocket. Getting 2 day out and 2 day pocket. 2 day out and 2 day pocket. 2 day out and 2 day pocket is 5 of 15 times 2 out of 12. Is 5 out of 18 times 2 out of 12, which gives you 5 over 108. Now, probability, now we ask the other one, probability of 2 day out, that is probability of getting pocket money. It can be probability of getting pocket money, it can be probability of 2 day out and probability of 2 day pocket money, or probability 2 day out, probability 1 day pocket money, or probability of 1 day out and probability pocket money. All this. We multiply this times this, that is 5 times 2 over 12 plus 5 over 18 times 10 over 12 plus 13 out of 18 times 2 out of 6. That gives you probability of getting pocket money. So you multiply all of them, you add, you will find 14 out of 27. 14 out of 27. Question number 5. The ages in years of 5 boys are 7, 8, 9, 10, and 11. That is the ages in years of 5 boys are 7, 9, 8, and 10, and 11. While those of 5 girls are 4, 5, 6, 7, and 8. A boy and a girl are picked at random, and the sum of their ages is recorded. Draw a probability space to show all the possible outcomes. Probability space will be, now we have boy here. If we have a boy of 7, 8, 9, 10, and 11, and we have a girl 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, like we're given. This is the girl and this is the boy. So the sum will be this plus this is 11, this plus this is 12, this plus this is 13. You add all this, you get all these 5 plus 7, 12, 5 plus 8, 13. You get all this is the probability space. And then we are asked to find the probability that the sum of their ages is at least 17. At least 17 means more than 17. 17 is inclusive. At least 17 is, so it's in 17 and above. So sum of at least 17 will be 17 here, 1, 2, 3, 4, 5, 6. It will be 6 out of the total, which is 1, 2, 3, 4, 5 times 5, which is 25. The 6 out of 25. The sum of at least 17 is 6 out of 25. That is the probability of getting the sum of their ages to be at least 17. So that is how we do it. You make a probability space as per the instruction given, and then you find what you're asked to do. Thank you to listening to this tutorial, and remember to subscribe. Remember to subscribe.